Hello students, in our regular classes we have already started the microcontroller and embedded systems, and we have seen what is microprocessor, what is the difference between microprocessor and microcontroller, and also we have seen one microcontroller, that is 8051, and also 8085 microprocessor. By this time you might be very clear between these two terms, microcontroller and microprocessor. And as I said earlier, all microcontrollers are microprocessors, but all microprocessors are not microcontrollers, and also I have made you clear in this aspect. So now we are going to see the architecture of PIC microcontroller, PIC. So in the earlier session, in our regular session, we have seen 8051. In this session, let us see PIC microcontroller. It is also one of the popular types of microcontrollers. So these are the content in unit 3. Already we have seen these topics 8085, 8051, and in next session, and we are going to see addressing modes, instruction set. Instruction set is 8085 instruction set, let us discuss here, and also timing diagram, applications in automation systems. I am planning to complete these topics, the rest of the topics in unit 3 in video sessions. I hope you are all comfortable with this mode of teaching, and for any clarifications and doubts, please don't hesitate to meet me. I will definitely clarify all your doubts. So let us see what is microchip PIC microcontroller. So it is from microchip manufacturer. So microchip is like Intel. It is also one of the major manufacturers in microcontroller sector. So here we need a software. We need a software, and we have a microcontroller, and this microcontroller is fitted or is embedded with different types of inputs and different types of outputs. Normally inputs are from sensors and outputs to actuators. So actuators do the work, and sensors sense or it gather the information from environment. So this is the simple microcontroller architecture, or we can say a simple schematic of microcontroller and its peripherals. And here you can see this is the board on which different elements are embedded. So normally inputs, outputs, and we have battery source and other elements like capacitors, resistors. Many elements are embedded here. So students, the microchip PIC, it is PIC microcontroller, and microchip is one of the manufacturers like Intel, and PIC is the family of Harvard architecture microcontroller made by Microchip Technology. The name PIC initially referred to peripheral interface controller. So P stands for peripheral, I stands for interface, and C stands for controller. So PIC microcontrollers were the first RISC type microcontrollers, so reduced instruction set controllers, and PICs are popular with both industrial developers. So in industries, PIC is very popular like Intel microprocessors or microcontrollers, and hobbyists like due to their low cost, wide availability, large user base, extensive collection of application nodes, availability of low cost or free development tools, and serial programming. So it can be reprogrammable. It is a reprogrammable device with a flash memory capability. So PIC microcontroller family, if you see, the 8-bit microcontrollers are available like 8051 in Intel. So PIC 10, PIC 12, PIC 14, PIC 16, PIC 17, PIC 18. So these are 8-bit, and then 16-bit microcontrollers are PIC24F, and I will tell you what is F and all. So PIC24H, and 32-bit microcontrollers PIC32, 16-bit digital signal controllers are DS PIC30, DS PIC33F. So these are the microcontrollers. These are the PIC microcontrollers with different capabilities and capacities. So PIC microcontroller product family. So here the F is a name generally indicates the PIC micro uses flash memory. So F stands for flash memory and can be erased electronically. And C generally means it can only be erased by exposing the die to ultraviolet light. So here in this type of microcontrollers there is a small what you call notch. So through that should be exposed to ultraviolet light so that the memory will be erased. So which is only possible if a windowed, so that is the window is provided. I said it is notch, and a package style is used. An exception to this rule is the PIC16C84, which uses EEPROM. So that is electronically erasable, programmable, read-only memory, and is therefore electronically erasable. So here you can see the table, and PIC microcontrollers, PIC17C, and this is the program memory, this is the memory capacity, data RAM, maximum speed in terms of megahertz, and IO ports, number of IO ports, those can be connected, and A to D converters are required. In few cases they are inbuilt, and in few cases the A to D converters are required in this capacity. For example, 16F877, it is a little famous, a popular type of microcontroller, and it requires this is the program memory, it is the capacity, and data RAM, and maximum speed is 20 megahertz, and IO ports 33. So 33 ports you can connect, and 8 A to D converters are required. So why PIC 16F877A is very popular? So here this is the reason. It is very economical. Apart from that, it is also very easy to be assembled, and assembly is also very easily can be accomplished. In additional components that you need to make this IC work is just 5-volt power supply adapter. So if you have 5 volts power supply adapter, you can incorporate this in your embedded system very easily. A 20 megahertz crystal oscillator and 2 units of capacitors, that is picofarads, 22 picofarads capacitors are required. So very easily you can embed this. And what is the advantage of PIC 16F877A? So this IC, so it is obviously an integrated chip, can be reprogrammed and erased up to 10,000 times. So you can reuse this. You can reuse this to 10,000 times. So even your mobile battery can be recharged. So obviously this many number of times, and similar number here 10,000 times. So therefore it is very good for new product development phase. And what is the disadvantage of PIC 16F877A? This IC has no internal oscillator. So internal frequency generator, it is not having internally. You have to connect an external crystal of other clock sources. So that is the drawback here. So features of PIC 16F877. So these are the features, key features. Maximum operating frequency, it is 20 megahertz. Flash program memory, it is 14-bit words, so 8K, and we have data memory 368, and EEPROM data memory bytes 256. IO ports, so these many IO ports you can have, and timers, 3 timers it provides, and CCP capture, compare, and PWM pulse width modulators 2, and serial communication MSSP, that is master synchronous serial port. So it has that feature. And USART, so it actually uses universal synchronous asynchronous receiver and transmitter type. And parallel communication PSP type. So PSP is parallel slave port. It uses parallel slave port, and 10-bit analog to digital module, that is 8 channels, and instruction set 35 instructions only. So very easy. So you can remember 35 instructions. And pins DIP, so dual inline package. So it is a 40 pin package. It is a 40 pin package. So the another advantages you can see here, the bubble diagram of PIC 16F877. So bubble diagram is nothing but the peripherals that you can connect to PIC microcontroller. You can see the PIC 16F877A is rich in peripherals, so you can use it for many different projects. So n number of projects you can execute using PIC. So this is the bubble diagram. You can see this is the PIC microcontroller. For that peripherals you can connect these many, right? USART, MSSP, CCP, and the PSP. You have the PSP. This is parallel port and parallel slave port, and you have ADC inputs, analog output comparator. So this is analog comparator. You have analog comparator, ADC inputs, and 10 pins, 10 bits. You can ADC. You can connect here. You have timers, 3 timers. So apart from that, you need one external oscillator and IO 33 pins IO ports, RAM, and program memory, EEPROM, right? So these are all the peripherals you can connect to PIC microcontroller, and these are the advantages. So it provides so much of sophistication by connecting these many number of peripherals to PIC microcontroller. So here the pin diagram, if you see, there are different types of PIC pin diagrams are available, and this is the quad flat package. So this is DQFP. So this is PIC, another PIC type of controller, and it's a pin configuration you can see here. And plastic leaded chip carrier package, PLCC. It is not actually required for your syllabus, just for your information I am sharing this. And you can see it is a 34 pin type, and you can see, sorry, 44 pin. It is 44 pin, and the plastic leaded chip carrier package, PLCC, and it is also similar to this. This is PLCC, and you can have either this configuration or this configuration. These two are popular configurations in PIC architecture, or PIC pin configuration. So the PIC architecture, if you see, this is the different elements of PIC microcontroller, and this is the diagram. You can redraw this into two-dimensional diagram, and this is the external oscillator and internal oscillator, and you have A to D converter, V reference. This is CPU. CPU, you have only 35 instructions. This CPU supports only 35 instructions, and serial communication ports. So that is SPI, I2C, SPI, IC, USART, and memory and SFR, special function registers. And we have RAM, EEPROM, and we have memory, and then we have reset. Power supplies. Power supply is 5.5 volts supply, 2 to 5.5 volts supply, and you have input output ports So port A, port B, port C, port D, port E, and port D is separated into two ports, and you have port E. So this many number of ports you have. So each port is having 8-bit size. So 8 peripherals or input output devices you can connect to each port. And if you see this diagram represents the internal architecture of a PIC microcontroller, highlighting how the CPU, memory, and timers, serial communication, A to D converters, PWM, pulse width modulators, and I/O ports interact. It shows that the PIC is compact yet powerful device designed for embedded system applications such as motor control, measurement, automation, and also communication. So these are the general applications of PIC microcontroller. And its pin diagram is it is also a pin. This is the chip, IC integrated chip, and it is a plastic dual inline package, DAP dual inline package, and it is also you have 40 pins, and this is the notch as we have seen the pin diagram in 8051 and 8085. You have to start counting from left hand side of this notch, and you have to count the pins in counterclockwise direction. So here this is the pin diagram. So it is given as only architecture in your syllabus. Anyhow, pin diagram, it is for your reference only. You can go through this pin diagram, and the different CPU different elements we can see here. So central processing unit, it is the heart of the microcontroller. It executes instructions, so 35 instructions typically for reduced instruction set. So that is the RISC instruction set. PIC MCUs, microcontroller units, and coordinates all operations by communicating with memory, timers, I/O ports, and peripherals. Memory units, so program memory 8K, non-volatile memory, that is flash, and which user programs are stored. So where the user programs are stored normally. RAM is 368 bytes, temporary storage for variables during program execution. EEPROM, it is 256 bytes. It is electrically erasable memory used for storing data permanently, so it can be calibration data, settings, all those you can store here. And SFR's special function registers, it controls control registers that configure MCU functions, so that is timers, in interrupts and ports. So this is the memory unit. Oscillator section, so it is oscillator is normally 0 to 20 megahertz, provides the clock signal that drives the CPU. Internal oscillator allows the MCU to run without an external crystal. So that is we have both. It is actually required internal oscillator. Unfortunately, except in that PIC microcontroller what we discussed, except in that almost all PIC recent microcontrollers from PIC family, they have internal oscillators. So timers, there are 3 timers, T0, T1 and T2, used for measuring time, event counting and generating delays. So essential for applications like motor control, frequency generation and real-time clocks. So serial communication, SPI and I2C, so supports synchronous communication with external devices, sensors, EEPROMs and displays. So USART, it is universal synchronous asynchronous receiver transmitter. For serial communication, normally RS-232 protocol you can use. RS-232 and other types of protocols you can use here. So that is serial communication. Next, A to D converter converts analog signals from sensors. So the signals from sensors are normally analog in nature, so that should be converted into digital in order to send it to processor or microcontroller. Obviously microcontroller is a digital device, it cannot understand the analog form of input, and you have to convert into digital and send it to microcontroller. Into digital values for processing, V reference, that is reference voltage, improves. So here V reference is used here, improves accuracy of A to D conversion. Next, CCP and PWM modules. So CCP is nothing but capture, compare and pulse width modulation. And modules used for timing operations. So PWM, pulse width modulation, controls motor speed, LED brightness and power electronics. And I/O ports A, B, C, D, E. So there are 5 ports, I/O ports. These are general purpose input output pins, drive to read digital signals from external devices. It can handle up to 25 milliamp per pin, so enough to drive LEDs directly. So you can connect LED to this pin and the LED will glow immediately. So with that 25 milliampere pin. So next is a watchdog timer. So that is WDT, a safety feature that resets the MCU if the program hangs or gets stuck in an infinite loop, improves system reliability. And reset and power supply. Reset brings the MCU to its initial state, and the power supply is 2 to 5.5 volts. So voltage range in which the MCU operates. Interrupt system allows the CPU to respond immediately to important events like timer overflow, UART data received, and external signal change. For these purposes, interrupts are used, and the detailed interrupts we have discussed in our 8085 microprocessor and 8051 microcontroller also. So embedded applications, so perhaps this is the last topic in our unit, and I am giving you applications here. Automobiles, handheld metering systems, mobile phones. So mobile phones, computer systems, security alarms, appliances, current meter, cameras, microwave ovens, measurement instruments, devices for process control, used in metering and measurement devices, voltmeter, measuring rotating objects, controlling devices. So these are all embedded systems required. And industrial instrumentation devices in industries, light sensing, safety devices, process control devices, controlling devices, fire detection, temperature sensing, mobile phones, automobiles, washing machines, cameras, security alarms. So these are the few embedded systems applications, and a lot more applications are also available, and we are not discussing those in detail since it is only one topic we are discussing in our syllabus. And let me differentiate between 8051 microcontroller and a PIC microcontroller. So these are the features in terms of feature. PIC microcontroller and 8051 microcontroller. Developer is microchip, that is PIC, and the developer is Intel. It came into picture in 1980s. Now produced by many manufacturers. We have Atmel, NXP, Silicon Labs, etc. And PIC, we have different series of microcontrollers. So architecture, modified Harvard architecture. And 8051 is a Harvard architecture, separate memory for program and data, but not as optimized as PIC. So separate memory is required here in 8051. And instruction set type, it is a RISC type, reduced instruction set computing, and simple fewer instructions, only 35 instructions, whereas it is CISC. It is CISC is nothing but complex instruction set computing. It is large instruction set. 111 instructions are present in 8051 microcontroller programming. So instruction execution, most instructions execute in a single clock cycle, so it is very fast. So one instruction takes 12 clock cycles in original, and that is in 8051, making it slower. So wherever you have CISC type of instruction set, it is obviously slower type of microcontroller, and clock speed operates from a few kilohertz up to 64 megahertz or more depending on the series. And whereas in classic versions run in 12 megahertz, modern CMOS variants go up to 33 to 40 megahertz, but still slower per instruction. So that is the drawback again here. And word size, it is 8-bit PIC 10, 12, 16, 18, 16-bit PIC that is PIC 24, 32-bit PIC that is PIC 32 available. So in 8051 it is only 8-bit, mostly 8-bit through some modern derivatives. They extend features but remain limited compared to PIC families. So here it is limited only. So this is one comparison, and we will discuss more features comparison. Memory organization, it is larger on chip memory, program memory, flash on chip RAM, and EEPROM available. Some families support extended memory addressing also. So here 4 KB ROM, 128 byte RAM, and 64 kilobyte external memory support. Modern variants include flash up to 64 KB or little more. So programming language supported by MPLAB IDE, and widely coded in C. Assembly optimized compilers are available. So these are you can MPLAB IDE is freeware, you can download and use with your PIC microcontroller, and traditionally programmed in assembly, now widely supported in C using Keil and SDCC and other compilers. So these compilers, it is also done in C using Keil. And peripherals rich set, ADC, PWM, timers, UART, already we have seen in bubble diagram, and the CAN bus, USB, Ethernet. So advanced models you can connect here. It supports only basic set, timers, UART, IO ports, classic 8051, lax ADC and PWM, available only in modern derivatives. And power consumptions very low, so nanowatt technology suitable for battery operated systems operates at 1.8 volts to 5.5 volts, whereas higher power consumption in original NMOS design. Modern CMOS 8051 versions have low power modes but not as efficient as PIC. So that is another drawback with 8051. And ease of use more complex due to wide family variations and configurations, however highly scalable. And here 8051 is simpler, easier to learn for beginners, very popular in academic training. So in almost many universities in electronics and interdisciplinary branches, they are explaining the microcontroller using 8051 architecture itself. So that is another way. And if you understand the working of 8051, I am sure any advanced derivative you can easily understand. So next feature in terms of feature code and availability, and here the slightly higher cost for advanced models but economical in mass production. So widely available worldwide. So that is 8051 extremely cheap and easily available. So instead of using cheap, you can use economical students. I will change it. Very common in education and small scale embedded projects. So development tools, MPLAB IDE, PIC-Kit, programmer debugger, extensive support libraries. So many varieties of libraries are also available. So Keil Microvision IDE, Proteus, and wide community support for simulation and training, and applications used in consumer electronics, automotive systems, industrial automation, medical devices, robotics, communication systems, used in basic automation, educational training kits, legacy embedded systems, household appliances. Whereas scalability highly scalable from 8-bit to 32-bit families, catering from simple to very complex applications, mostly limited to 8-bit systems, less scalable compared to PIC, and future scope. You can see here still evolving with advanced architecture. PIC32 competes with ARM Cortex M, and considered a legacy microcontroller, still taught for its simplicity but less used in cutting edge designs. So 8051 is not much used nowadays because of ARM processor. We have PIC processors, even Arduino controllers. So there are so many controllers have came up. So with this we can wind up this PIC microcontroller and its comparison with 8051. And it is comparison is a very important question, students. Please prepare well for your internal exam. And so coming to references, you can refer this book, a simple book. This is Ankaj Gupta, Fundamentals of Microprocessors and Embedded Systems, by S.K. Kataria and Sons Publishers. And you can refer this book. It gives more information on microcontrollers and embedded systems. We stop here, students. We will meet again in video mode to discuss one more topic, and we stop here. Thank you, students. For any clarification and doubts, please approach me, and don't hesitate. You can always approach me for your doubts, students. Thank you.